ご参加の皆様、本日はMySQL テクノロジーカフェご参加いただきまして、誠にありがとうございます。今回は初めての試みですね。オンラインで、しかも海外スピーカーをリモートで呼んでみるという形の企画となっております。開始に先立ちまして、いくつかですね、ご案内をまずはさせていただければというふうに考えておりますので、そのあたりお付き合いください。で、まずはじめにですね、ハッシュタグ、MySQL カフェ、MySQL アンダースコアカフェ、こちらで、皆さんのツイートをぜひですね、感想、ご意見等をお待ちをしております。で、この MySQL テクノロジーカフェをはじめとしたですね、夜やるイベント、特にデベロッパーの方向けのイベント、オラクルコードナイトというイベントで、ここまでやってまいりました。昨今の状況もありますので、しばらくはオンラインのみという開催になりますが、これからもですね、ほぼ毎週、いや、毎週どころか下手すると週に2回とかあんじゃねえぐらいのペースだと思いますが、オラクルクラウドに関する全般のですね、技術的なお話をするオラクルクラウドハングアウトカフェ、通称お茶カフェ、それからブロックチェーンに関するセッションだったり、オラクルデータベースのイベントもあります。でこのほか、ビッグデータにフォーカスしてみたものを APEX ですね、コードを書かずにアプリケーションをサクッと作れるアプリケーションエクスプレスというのがありますので、このあたりをご紹介するイベントなどをですね、結構実運用例とか、ディープな話が来る回もありますということ。お茶カフェも今ちょっと若干お休みの、ちょうどですね、シリーズの境目になっているような感じですが、また近いうちに、確か7月の下旬からだったと思いますが、新しいシリーズがスタートしますので、そちらもぜひお楽しみにしていただければというふうに思います。また、MySQL テクノロジーカフェに関しては、次回ですね、もうすでにざっくりと決まっていて、おそらく7月の下旬、今、仮の日程で7月26日だと思いますが、7月26日に、ユーザー会の、日本 MySQL ユーザー会の皆様にですね、ご登壇をいただいて、つい先日5月の23日に MySQL ユーザー会との20周年とですね、MySQL の25、ごめんなさい、7月じゃなくて8月ですね、失礼しました。8月26です。大変失礼いたしました。8月26日に、日本ユーザー会のイベントをやります。25周年、MySQL 25周年と、MySQL ユーザー会20周年の合同イベントありましたが、それもですね、なかなか盛り上がったイベントだったので、またその延長戦じゃないですか、また違ったネタも出てくると思いますので、8月26日でほぼ確定、ぜひですね、ご参加いただければと思います。ハッシュタグ、覚えてます？MySQL アンダースコアカフェ、これをつけて、次回は8月26日、日本 MySQL ユーザー会の皆さんが登壇するんだって、いうのをですね、ぜひつけていただければと思います。はい。本日ですね、一応、この後6時10分頃からですね、私のパートさっさと切り上げて、フレットに早く渡せればなと思います。今日のメインスピーカーは、MySQL コミュニティマネージャーのフレットです。通称フレットと呼ばれています。彼からですね、MySQL、ごめんなさい、Python のデベロッパー向けということになっていますが、Python を組み合わせた使い方、SQL 的にもちろん使う方法もあれば、NoSQL として使う方法についてもご紹介をさせていただく予定です。それから本日のセミナーの資料に関しては、近日中にですね、イベント終了後、近日中にコンパスのお申し込みいただいた時のサイトの方に掲載予定、動画に関してもですね、コードナイトの動画を集めたページがありますので、そちらの方でセッションの部分のみ公開予定でございます。本日のスピーカー、フレット。皆さんすでに一番下の URL、lefred.be、ベルギーを表す B らしいです。で、イルカのロゴ、イルカ抱っこしているやつありますが、写真ありますが、ここにですね、オラクルクラウド OCI の上で InnoDB クラスターを構築するにはとか、各種のですね、実践的なトピックのブログの記事が掲載されますので、ぜひここを追いかけていただければと思いますし、彼の Twitter のアカウントでもですね、頻繁に情報出てきますので、ぜひ見ておいていただければと思います。では、本日のメインセッションに移っていきたいと思います。フレッ と、MySQL のですね、コミュニティチームのもう情報発信大量にしてくれているメンバーからご紹介します。Fred, can you prepare your slide, please?
Okay.
I see your screen.
Perfect. Nice picture outside of my house. So thank you for having me today here at the MySQL Tech Cafe. So today I will talk about MySQL 8 for Python developers, and use the hashtag MySQL Cafe, but you can also hashtag use MySQL 8 is great, which is something I really like to say often. For every MySQL or Oracle slide deck, you have this slide that people should know, but in case of, it's there. And when I will share the slides or when you will share the video, people can read it more carefully. But this is the safe harbor that it's mandatory for us. So you already said a lot about me, so I won't spend too much time, but you can follow me on Twitter. If you have any question, you can ask me there, and I will be very happy to answer you. So I'm managing MySQL since a long time. I just discovered because it was our 25th anniversary. So I make some research about my first version I ever installed, and it was 3.20. So it's a very long time already. I'm a DevOps believer. I'm living in Belgium. I think I heard you said France, but I'm not sure. But I am from Belgium, and this is my blog where you can find a lot of information. But I heard Kajama-san talked a bit already. Just for proof, so you should see what I say and not only believe. This is what I found out last month when I was looking. My first installation of MySQL was 3.20. So it's in 1997. So it's a long time. So let's start with MySQL Connector Python. So this is what developers for Python developers will use to connect to MySQL, right? So we have this MySQL Connector Python 8, which is GA since April 2018. So it's already 2 years now. And yes, it's yet another connector in the Python world because there are several ones. And but this one, it's maintained by Oracle, so by the MySQL engineers. We maintain this code and we release it at the same time as we release the server. It has dual license, so if you have a asking question about licensing, if you have some projects that you want to do embedded code or so, just you can reach out ourselves and we will explain you how it works. But it's GPL also. So it supports MySQL Server 5.6, 5.7, 8.0. Don't forget that 5.6 will be end of life in February, so it's time to upgrade. And it also supports SQL and NoSQL. And this is what I will also show you today. And because we can do SQL and NoSQL, it can also work with relational tables and JSON document. So MySQL Connector Python has 3 APIs, and you can choose them, of course. The first one is the MySQL Connector, which is the traditional API that you should be familiar with. Then it has also the _MySQL _connector module, which is the C API for MySQL. So it is available. I don't know a lot of projects using it, but it's there. And the new one in MySQL 8, which allows us to do SQL and NoSQL, which is MySQLX. So all you need to know, it's on the documentation, of course. And you can go there if you want more information about what type of APIs do you need. But today, you're going to see, we will talk about the MySQLX API. Also, the connector for the MySQL Connector Python, it's compatible and supports Django. So if you have a Django website, this is how you can use this connector. But right now, it's currently supported all the Django up to 3.0. So the 3.0 is not yet there, and we are working on it, and it will be released soon. But so stay tuned. If you already upgraded to Django 3, then the connector, our connector, is not yet supporting it. So how can we install the MySQL Connector Python? It's the easiest way is to use pip. That all Python developers should be, let's say, aware of it and familiar with it. So this is how you install it, and you can see it's quite fast. And this is how you install the latest version. As you can see, like I said earlier, the versions are in sync with the server version. So MySQL Connector Python is 8.20 for the moment. But you can also use the repository. So it's part of the main distribution. You can install it using the package manager, which is DNF for Fedora, Yum for Red Hat or CentOS, and so on. You can also install it and download it from our website. So you can choose your distribution, or if you want to have a compiled version, or you can get the source from here too. So this was about the installation, and as you can see, it's quite straightforward and easy. So let's see how we can use it now. And the first thing we do, it's how we use it the classic way, right? So if you want to use the MySQL connector for Python using the classic protocol only, you use this syntax, right? So as you can see, we do import MySQL connector, given here we call it as MySQL. Then we connect with the usual, let's say, settings or attributes, parameters. Then we open a cursor, we do our query, and then we execute the query in the cursor, and then we can fetch the record and do whatever we want with the records. So this is how it works by default with the MySQL connector connecting to the classic protocol. And this connector using this MySQL.connector allows us to connect only on port 3306 by default, but of course you can change the port of your server, but it only understands the classic protocol. So I will go after explaining you a bit what's the new protocol. But if you try to use this connector with this API to connect to the new X protocol port, you will have this error that will show up that says, oh, watch out, there is a mismatch because your server is speaking protocol version 11 and you are trying to connect with the client that only supports up to version 10, right? So the easy way now, it's using the X protocol, the new one. So how we do that? Instead of importing MySQL connector, we use MySQL X. So we import MySQL X. We give some parameters again. As you can see here, the port is the default one, but I added it in the slides. It's 33060. So this is the new port for the X protocol. So it means that if you install MySQL 8 by default, it will open two ports for the connection. One 3306, which is the classic one, the one that you always use until now, and the 33060, which allows you to do X connections. With the X connection, meaning that you're going to use the XDev API, which allows you CRUD operation that I will show you also after, and that allows you to do async calls and stuff like that. So it's a new protocol. We didn't want to break the classic protocol, of course, but the modern languages need new stuff, and so we had to extend the protocol. And instead of breaking what we had, we create this new protocol, which is the X protocol. So we open a session with MySQL X. So this is how we work. We do a MySQL X get session, and then we do a query if we want to use a standard SQL statement. And then we put that query in the SQL method of the session, and we need to execute it. Then it's almost the same. We fetch the results, and in that result sets, we can loop and check the data we need. So now let's go a bit further. So what we can do with MySQL 8, Python, and the X protocol, it's JSON. So I don't know if you are aware of it, but since MySQL.5.7, we have the support for the JSON data type with a native data type in MySQL. And thanks to that, we are able to create what we call the document store. But I will go on that soon. So what's JSON? So JSON is the JavaScript object notation, and meaning that you can create documents, and the documents looks like what we have now on the screen. So it's completely schemaless. So you don't have a table with relation and with columns, and what type are the columns. It's just a document, and you put whatever you want in it with some structure or not, meaning that two documents can have different attributes. It's possible. There is no limitation on that by default, right? So like I said, we have this support of JSON data type, completely a native one, because before that, people, when they wanted to store documents, they were using large text files or blob to put that data, but this had a lot of inconvenience. And now with the JSON data type, all these inconvenients are away. If you want to know what are these inconvenients, for example, the partial update was not allowed. So let's say you had a document of 1 GB, and you are using a long text to put that 1 GB document, and you wanted to change one small attribute, maybe 1 byte only, you had to rewrite the full gigabyte on InnoDB, so on the storage engine, meaning you will have a big gap of 1 GB in your table space. Replication the same. You want to modify 1 byte, you have a document of 1 GB, you had to replicate the full gigabyte to the replicas. So this is something that you don't have with JSON data type. Plus, it's stored as a binary object. It supports, like I said, the partial updates for replication or for updating the storage engine. And also it has more than 30 JSON functions. So with this function, you can do manipulate these JSON documents very easily, which is not the case when you are using, when you're storing your documents in text columns, right? Or of course, because it also supports the JSON path, so it's very easy to address the attributes you want. And this is a small summary of what are these shortcuts and this attribution. So we use $ for the root of the document. The separator for the path is the dot. You can support wildcard. Dot star with all the members of the object. We have values in it, and you can do a lot of other stuff. So it's very, very easy. And we will see that we improve, for example, for the arrays, we had to improve indexing and stuff like that. But I will cover that soon. So some word about the full document store solution, right? It's built in on MySQL Server, of course. MySQL 8. So as soon as you install it, it's there. No need to have extra stuff. And so it's built on the JSON data type and the full MySQL Server technology. So it will provide to the developer the ability to have a very flexible schema, because he's schemaless. So he can store whatever he wants. Like, oh, my application is writing that information, and I want to write it as a document. You can do that. And then you say, oh, but in my new version of my application, I will have a new attribute. Do I need to modify everything? No need. You just have to add the attribute in the document you want, and that's it. You don't need to recreate the table or lock or whatever. So when you are using that, it's you don't need to know SQL. You can work with without SQL with CRUD operation, and I will show you that in a moment. And like I said, you don't need to define all the attributes. So different objects may have different attributes. This is possible. To use the document store, you will use, and at the full capability, you will use the new Xdev API, right? So and we're going to see how it works with JSON, and you can, of course, manipulate them. Something compared to other document store on the market is that the document can be almost 1 GB max size, which is much bigger than the limitation you have with one of the let's say the most popular NoSQL database right now, which is 16 megabyte. So and 16 megabyte for me, for myself, I was expecting this was very large number already. But I saw a lot of people complaining that 16 megabyte, it's too low for a document. I don't know what they put in their data, but 16 is too small. MySQL gives you 1 GB, so it's much bigger. Of course, with the document store, you can use all this new modern programming language and style, and embed everything, and very easy to read. I will show you some example, but all dedicated on Python, but you will see that we have connectors for other languages, not only Python, of course. You can also work with relational tables, so you can mix both, which is very useful. And of course, it all rely on the proven MySQL technology and also all the ecosystem around MySQL. So if you are using third-party tools to do anything you wanted to do in MySQL, it's still possible to do it because the server didn't change. It's the same stuff. So you still do your replication the same way. You still do your backups the same way. All that, it's still possible with MySQL document store. So like I said, we have multiple connectors that we provide. So we provide connector for C++, for .NET, for Node.js. Node.js is also something very, very popular. For PHP, for PHP, it's maintained by our developers, but it's still from the PHP community. So from Python and from Java. And the Xdev API, so when I have this X protocol enabled, so it's an X plugin, what is it enabled in our server? What can I do? So I can do SQL, like I showed in the first small example, but I can also do NoSQL with JSON document. I can also do NoSQL on relational tables and all that. And the API is the same across all the platform, all the language we have. It's the syntax is almost always the same. So like I said, we provide connectors for multiple languages, and we are working with other communities to support this, but that takes time. We have a new tool in MySQL, which is the MySQL shell. MySQL shell is a wonderful tool that you can extend in Python if you want, or in JavaScript. And with the MySQL shell, you can also do work with the Xdev API and do all this operation from the shell. I will show you also that. Something also very important is that this solution is full ACID compliant, which is not the case of all document store. When you plug out the power, you may lose data. With MySQL, we don't want you to lose data. So by default, we are ACID compliant. There are save points. And they have also, in the Xdev API itself, we have a connection pool since 8.0.13. So this was about the theory, a lot of information. Like I said, you will have the slides. If you have questions, please ask them in the Q&A and I will answer on that. Now I will show you how to use all this wonderful stuff. So the first thing we do when I ask, usually I give this kind of presentation in front of people, not in front of my computer. And if I ask people what are the NoSQL database they know, a lot of people says, oh, we know MongoDB, which is, even if they change license, it's still very popular, right? And so if we want to migrate the data out of MongoDB to MySQL document store, is it a complicated operation? No, I will show you. So for example, we have here in the restaurant collection. Restaurant collection, it's a very known collection that you do when you install when you do this MongoDB tutorial. So here we have this collection restaurants, and I will use the Mongo export to export that collection on a file. As you can see, it exported a bit more than 25,000 records, so documents. So now what I need to do with that, I will show you an example. And in Python, using the shell, you can do one command from the command line if you want, or use it in JavaScript, but I want to do Python because it's a talk about Python. So the first thing I do, I will create a schema to store all that, and I will call it docstore. Then I use it. So what you see here, it's the shell. And you can see I'm in Python. Then I do, okay, I will do the import of that document. And it was done very quickly, you can see. And this is done. Nothing extra. We have just imported all these documents in the MySQL. We have exported from Mongo, imported in MySQL, and they are all in MySQL now. It's cool. It's easy. Yeah, people don't like it because it was too easy, right? So now that we have these documents, what can we do? So we can query the document. So I am still in the shell and I do, okay, I have my collection. My collection is restaurant. You can see here that we are in docstore schema, and this is the collection name. So I will do find my document, but this is way too much for one small slide because it will return me more than 25,000 documents. So let's add a limit to this query. So I will add the limit of 1. Give me 1 document. And this is the document like it is in MongoDB. It's just a JSON document stored in MySQL. And in MySQL, this is how the document is stored. It's not like we split it in pieces and created a lot of relation or a lot of columns and stuff like that. No, we store the document like it is in MySQL too. So now that we have that document, we can play with it or with the collection, I mean. So we want, for example, in this case, we want to say, oh, I want to find in my restaurant collection, and I want to return the name and the cuisine attributes only, nothing more, and limit it to 2. You run that very fast and it tells you, okay, these are the first 2 restaurants we have in our collection. This is their name and this is the type of cuisine they have. So this is also something very easy to do. Now you say, oh, let me add some criteria because my application needs to search for something. It's also very easy. In the find method, you can give parameters. And in our case here, we're gonna use cuisine has to be Italian, right? Here, cuisine has to be Italian. And it will return the first 2 restaurants where the cuisine is Italian. We can go more than that. We can use in. So within, you can say, okay, I want that the cuisine should be in this list. And the list in this case is Turkish and Italian food. And we have the first 2 restaurants that match that criteria, right? That filter. So it's very, very easy. The syntax now, it's different than MongoDB because our goal is to make the people to use this technology much easier than anything else. So we want, because most of the time I see, because I go also to schools, high school, university, talking about MySQL, and people, they don't like SQL. The new student, they don't like that much SQL, and they think it's sometimes complicated. And I can agree with them. And now we want to make something very, very easy for everybody. So if we check this, and usually when I'm live on stage, I ask somebody in the audience to read this statement and to tell me what it's doing. I ask that to somebody that never used NoSQL before. And let's do that exercise together, even if I know how it works. So we are asking to the system, please in the restaurant collection, find me the documents where the cuisine has to be French, where the borrowed should not be Manhattan. From this document, return only the name, the cuisine, and the borrowed. And I want that you limit that to 2 restaurants, so 2 documents only. And this is how it works. And this is what we have. So it was very easy to construct or to build this query. In MongoDB, if you want to do that, this is the same query, but the syntax is different. If we don't want something, you need to do a regular expression like that. If we don't want to have the ID, because the ID is always shown, we have to put it to 0. But if we put it to 0, we need to put 1 to all the attributes we want to see. So for us, that our goal is to make this solution very popular and very easy to use for everybody. For us, we think this syntax, it's much easier than this one. But this is our goal and our thought, right? So it's up to everybody to decide. But this is why our syntax is different. So this find that we are using now here, it's one of the CRUD operation. And we have other CRUD operation like remove. So we can see here, I was doing this query and we had the first 2 restaurants were La Baraka Restaurant and Air France Lounge. You see my French accent is very good. When we delete 2 records, we do again, and you can see that the previous 2 records or documents are removed. And now the next 2 are Bartaba and Tournesol, right? So because we can do find, so it's one of the CRUD operation we discovered today together, and remove. But we have operation for multiple operation for all the collection. So if we want to add a document, we use the add method. And this is how it works. You can add documents and put them one after the other, different add method to the same collection, or you can put them all together in one array and it will work. So it's very easy to add a document. If you want to modify a document, you can you say, oh, I want to modify the name. You can also bind. This is the modern way to do stuff. So you can also bind what I was saying, variables or attributes like this. And this is very easy. Something I really like to modify a document, it's the use of patch. So you can create a new patch with extra method or modify a method, extra attributes or modify an attribute. And when you run that, it will just apply the patch. So this is very, very easy to do. Remove a document, we already saw it together. So we use the remove CRUD operation. So this is a small summary of the CRUD operation that we have. And you can see we can work on the database itself. So we can get the session, get the schema, get some names. Then we can work on schema. So we have CRUD operation for schema. We have also for collections. Collection are all these JSON document together. This is what I just show you. So add, find, modify, and remove. We can also create an index, drop an index, get some index, create a new document. But we can also use CRUD operation, insert, select, update, delete, the same way without typing a full SQL statement for a relational table. So this is very easy. So if you want to know more about this, we have also all that in our document. So we can use MySQL without knowing one single line of SQL statement. So this is quite cool. I saw there was a question on Twitter about can the X protocol support async communication? Yes. So now let's see the CRUD operation in Python, how we can deal with that. So let's go back to the small code I wrote here, right? So nothing complicated, just the connection. Then I want to take the doc store schema. I want to have this collection restaurant, and I want to find all the restaurants with the cuisine Italian. This is the field I name, limit to 3, and execute. Then I want to just fetch all that information in the rest that I've been put in the restaurant result set and print them, right? Then I code my session, and the output will be this one. So yes, if it was not yet obvious, even if I saw it several times, you can now use MySQL without SQL. This is wonderful. So I explained you that we have that we are ACID compliant because we want to be very careful with your data. We saw that we have document store. We saw, because we can store this JSON data, we saw that we have CRUD operation, so we can use it without knowing one single statement in SQL. But what makes the MySQL document store unique? Why is this solution the best? I will try to answer you this question. So this is a challenge. If you want to list the best restaurants of each type of cuisine, of each type of food we have in the collection, and show the top 10 of them with the best one first, so sorted. How do you do that in NoSQL? And don't forget that all that data are just pure JSON documents. How can you do that in NoSQL? The answer, it's easy. It's impossible. You can do it by retrieving all the data, then make all the calculation you want inside your application to display that. It's very complex. With MySQL, it's possible to do something different. And let me show you. So this is the answer of the challenge. And you can see here that the best restaurant was Juicy Health Bar, with the cuisine was juice, smoothie, fruit, and salad, with an average score of 75, right? So for each type of cuisine here, we have the best restaurant, and they're all sorted by their score. So how were we able to do that? And we did that very fast. This is a few seconds. We use all the new capabilities of MySQL 8. Because if you don't know yet, but we have extended SQL in MySQL 8, the support of new feature that were requested from our community and customer for a long time. So we have common table expressions. So here we create a common table expression. We use a Windows function for the ranking, right? And we fake for MySQL, for the optimizer, we tell them, okay, this document, I will retrieve the information I need, like if it was a relational table, and I use JSON table. So when I put all this together, this is more complex, of course, than CRUD operation, but sometimes analytics are needed. And previously, how people were doing that stuff when they were using just a NoSQL database, it's easy, but it's not easy to implement. It was easy in the concept was, okay, let's store our data in NoSQL. And people were doing that. Then after a while, and when the application is running, somebody says, yeah, I need to do analytics. The back office needs to know what's going on here. Can we do analytics and on that data? Then the developer was like, no. So I need a solution. How we do that? We need to extract all the data from the NoSQL and put back, and not even in real time, on a relational table to be able to run this analytics. With MySQL, no need for that. You just need to be able to write a good SQL statement, but the data is exactly the same and it's not duplicated. It's all on the same server. And this is how you do that. So how can we use this in Python? Again, this is exactly the same program we did earlier. And now what we do here in the same session, this is very important, we are in the same session, I just run one SQL statement. And this is the SQL statement. Of course, maybe this is complicated to write if you never saw Windows function, never saw CTs, but once you get used to it, it's more common. And I think it's much easier to write this 6-line code than create a full architecture that needs to pump the data from your NoSQL and put it in a relational table, where at the end you still have to write this analytics queries using Windows function and CTE anyway. And then we display everything here. So the output of that piece of code will be the first 3 restaurants we had, and then the result of the query, which is here. Then you tell me, yes, Fred, it's good, but since now that you convince us to use document store and JSON, it's because we want to use JSON, and my application now used only JSON because you told us JSON is cool, JSON is supported in MySQL, so we decide to use JSON everywhere. So when we do this, it's cool, but my application now, because of you, consumes only JSON. What can I do? It's easy. You can say, okay, please return JSON. So we have here, we say, okay, return a JSON object of that query, of that SQL query, and the output is just JSON documents. Then your application can consume that and do whatever they want. So this is very easy to use, and the new application, the new modern application consumes only JSON. We give them only JSON. So now we saw this is cool. Some extra. Let's see, because for once I have some time, which is cool, to see what's under the water, right? To see how it works. The first thing is that every document, they have a unique ID, which called the document ID, and it's represented by this underscore ID, which is quite popular in NoSQL. And since 8.11, this ID is generated by the server. If you want, you can force one, but it's generated by the server, and it has been generated on a way that it's also very good for InnoDB, because if you use random UIDs and stuff like that, it can be very bad for InnoDB, because you will have a cluster index that will be rebalanced every time, because every time you create a random number that is not sequential at all, you will have to split the page to put the data, because the data in InnoDB, it's stored by primary key, by the cluster index. So to avoid that, we have created a very good one, a method to create these random IDs, but that they are also sequential, to not have to rebalance the cluster index in InnoDB every time. So this is an example how it works. Like I said, we are ACID compliant. So, and why this? It's because we rely on InnoDB. Like I said, we store the ID for InnoDB, and because all the documents are in InnoDB. So how we do that to achieve this full durability? We use InnoDB flush local transaction commit equal 1. This is the default. We have the double write buffer on by default. We have syn bin lock on by default, and we can play with all the transaction level we want. Because something that is very important to know about MySQL, and this is not only about the document store, but about MySQL, if you use MySQL, it's that we do care about your data. If you use MySQL, we don't want to lose your data. Now, of course, you can mess up with all these settings and have a full non-durable system, but then you pay the price that you may lose your data. But if you use the default, if you know, and if you don't change anything, by default, we are very durable and we care about your data. So what time is it now? So now it's time for some more examples, because I wanted to show you example how to use that and how cool is the solution. So maybe I think everybody knows this TV show, The Walking Dead, right? Nothing to do about the situation, I guess. So we're gonna import these shows that you can find on the internet, all the shows, and I insert them in my document store in MySQL. So if I want to say, oh, please give me all the episodes of the season 1, then I can use a very easy CRUD operation, say, okay, season equal 1, and give me the name, the season number, and the air date, and this is how it works. So this is the very easy way to query your document store using the CRUD operation. Now, if you say, oh, but I want to list all the first episode of each season. Okay, I want that the attribute number is 1 and give me the name and the season. And we can see how it works, and very easy to do too. Now, I want to make a lookup by name, right? And how can I make it faster? So for example, I want to say, you can create an index and say, okay, I want to create an index. My index, I will call it name underscore IDX. And the fields will be, remember, I said this is the root of the document, the dollar. So I will go $name, and the type will be text20. So even if the title it's bigger, the name is bigger than 20, to index it, to find it, 20 it's enough. I will limit my index to 20. So now if I search for a movie, a series, so the name of the episode, like First Time Again, you can see it was very fast. And of course, because even if you use that, your MySQL DBA will use the usual thing he knows to optimize everything, to check what's going on. And we can see here that if I run the explain for the query, if I check here, not the explain, but if I check the index statistics, but if I run the explain, it will be exactly the same. If I check the index statistics, I can see that my name index has been used, and it has selected one row. And this is statistics about all the index we created to see which one are most used, which one are not used, and stuff like that. So we can see that now our index is used. Like I said, we are ACID compliant, so we use, I show you an example of durability. Let's see an example of isolation. So now I want to first find a document, right? An episode, and this episode should be the 9th episode of the season 9. And this is the episode, the name was adaptation. Now we start a transaction, and I want to remove that document. Then I do a find again in the same transaction, and I see that it's empty, result set is not existing. I will roll back my transaction, I check again, and it's still there. So we support transaction even in document store, right? So for all this easy stuff, I could do it. You see, I am still in Python mode, and I can do it with CRUD operation. Now I say, I want to find the amount of episodes per season. How many episodes were there? This is quite complicated with a simple CRUD operation. So in SQL, this is much easier because we have the group by, so we can do it, and we can see here for every season we have that information. But don't forget, this information it's stored in JSON. So this is why we are using this notation here to get inside the JSON to retrieve, so unquote extract, and do our queries to it. So now I want to have more statistics for each season. And in this case, I want to know for each season, what was the max duration of an episode, what was the minimum duration, and what was the average duration. So you can do that also with Windows function, like I'm doing here per season. And you can see it's very easy to do that, very fast. You see the time it took to do that? It's very fast. Of course, it's a small database, but it's very easy to do. Let's make it even more complicated and see, oh, I want the number of days between each episodes and the number of days since the first episodes. And we can see that we have here, we can see that the season 2 came almost 1 year. The first episode of the season 2 came almost 1 year after the episode of the first season, right? After it was less days, like 77 days between the season 2 and the season 3. So it's very easy. You can do analytics, check stuff from your on your document. So I want to show you still something very cool. It is possible to use to make some data validation. So people always ask us, oh, we want to do schemaless. We don't want to have any limitation. Okay, we will give you JSON documents with schemaless. But it's like usual. Then people, when you give something, they want more. And they say, yeah, but now I want that my JSON document has some validation into it. Okay, we can do that for you. So, for example, in our case, we can have, we can make constraints in MySQL between collections or between collection and tables very easily. So in this case, I will create a new collection that I will call rating. And then I will say, okay, a document, I will add the document, and the document has an attribute called user, an attribute episode, which is the ID, the number of the episode, and the rating I give it, right? And I add it, and you can see this is in my new collection, there is one record. So if we want to have a look of how it looks like in MySQL, and that may look a bit scary when you see that. This is not needed to see that, but so a document, a collection in MySQL is in fact the doc as a JSON data type, the ID that is generated, like I said earlier, and it is also stored in the JSON document, the primary key, which is the ID, and this is the index we created earlier. So it makes a random date here, the random column, which is this column, which is also a virtual column generated. So we'll retrieve the data out of the document virtually, so we don't put it anywhere, just to be able to index it, because the index needs to be materialized on disk, on memory, and everything. So, and the index must be maintained. So we need to do that. And for that, we index this fake column or this virtual column, right? And here we did the same. So we have a document, an ID, and there is no index anywhere here. So no need for it, just the primary key. So now we have that. We will create a new generated column like we did like the system did it automatically for the index. So we could do the same, we could just index it, but I wanted to show you how we do that in SQL. So for the rating, I will just extract the episode ID, so the episode from my document. And for the shows, for the event, I will also extract it as a virtual collection, a virtual column. After that, I will here create a foreign key, right? So I add an index of this virtual column, and then I will add a foreign key to make this relation between the rating and the episodes we have. So now, when I have this relation, I can validate that if I create, so here we can see, this is the SQL way to show that. So we see that we have created this virtual column ID, this virtual column episode ID, and we have this constraint here and the index, right? Then because of that, now, without doing any SQL, just using the CRUD, I can say, okay, give me the episode that has ID 1, 2, 3. There is none. So should I be able to rate that, that episode? So if I create a new document and I want to rate that episode right here, when I will add that document in my rating collection, it will tell me, no, you cannot update this, you cannot add this document because you are trying to rate something that doesn't exist. So you are not allowed. So this is one way of adding some validation, but there is more. So now since 8.16, MySQL also support check constraint. So something wonderful in MySQL, and we will see how we can use that. So for example, I will say now, okay, the rating needs to have a constraint that it has to always be more than 0. Then I will add another constraint. It could have been on the same, but I want to show you how to add constraint. And it has to be less than 21. So from 1 to 20 is the rating I can give. So now if I create for an existing episode, because this one exists, 4097 exists. If I want to create a rating with it's above the limitation, here also we can check that and MySQL will return me an error, say, oh, the rating you are giving, it's too high, right? So that was cool in 8.17, in 8.16. In 8.17, we added even more. So now we have new JSON schema validation function. So we can create a validation string or information about the JSON document. So in this case, what I do, I say, okay, the name should be a string, and that string should not be bigger than 30, right? So this is how, and I put that in a variable, but this is the validation. Then I can do here, please use the JSON schema valid function at the variable of the validation I want to do and the document, and it will tells me which documents are valid or not. Then I can also use a report to see why they are not valid. So I run it and I see it. So these two functions are added in 8.17. The first time I saw that, this was my reaction. Say, whoa, cool. I don't think that's very cool, right? It is cool, but it's too late. The documents are already there. So I can see afterward that they are not good. I can see why they are not good. But does that help me that much? Not really, right? But if we mix both words, so the JSON schema valid function plus the check constraint, like I do here. So I will add a constraint called max length name, right? And I want to add this check constraint on the JSON schema validation I want to create. Then I add it. Now we are having something cool, because now if I add a new document that is not valid compared to the validation I wanted, it won't allow me to write it in the database. And this is something very cool, right? MySQL 8.0, so with all that, we can also say bye-bye to ORM. So if you are a DBA like me, ORM, it's a nightmare, or at least I don't like it. Sometimes it joins 10,000 of tables to just display one column. It's very boring. So this is one very known ORM for Python developers, which is SQL Alchemy. And at the beginning, a lot of people likes it. Then when we talk to the Python developers that are using it a lot, they hate it like the DBAs. But this is how it looks like. If you use MySQLX like this, you can store and retrieve a full Python object and store it as a JSON directly on the database and retrieve it. So you don't need to pass by that ORM that will split your document, your object into tables and put it back, because you need to maintain that stuff when you want to change an attribute and stuff like that. This is not needed when you use the X protocol and JSON documents. And to finish this, Python community are also is also big with Zope and Plone users, right? So if you know that if you are using Plone, for example, or Zope, there is this ZODB, right? It is as a DBA, I don't really like it. And then if you want to scale out your Zope and Plone, let's say, site, at a certain point, ZODB becomes a bottleneck. So it's better to store all these objects that are in the ZODB on a database. And it is possible to also use, since real storage tree, to use MySQL as backend. Currently, it uses that backend, but it still splits it. Maybe we should, I should check with them to see if they could use the MySQL X protocol to do that. But it's also already possible to use, and it supports MySQL 8. So this is, and it's even recommended to use MySQL 8. So this is very good. So what do I gain on that, right? If as a developer, so if I use MySQL as a Python developer, I can gain data integrity, but it was exactly the same already when I was using old MySQL or another database, depending which one, of course. It's ACID compliant. I have transaction. I have SQL. So it's nothing that new. But now I can also have schemaless. I can have this very flexible data structure. I can have very easy starting process and proof of concept, stuff like that, because I don't need to think about how I will design my data or I will make this model. I can just do CRUD operation and store everything in JSON. And I can use NoSQL, so it's very, very cool. If you still have looking for reasons to move to NoSQL, here it's one of very popular blog posts about the 10 reasons to move to use NoSQL with MySQL. You can do much more if you're a Python developer with the MySQL shell. You can create your own tools to do that. So it's very, very nice. I really encourage you to do that. I am sharing a lot of plugins for MySQL shell and MySQL on my GitHub. So feel free to see. And you can extend it without a limit. It's very, very easy. There is a reporting framework. You can run reports in the shell also very easily. And since 8 to 16, I have some reports made if you are using cluster or whatever stuff you need. Like I said, we have since 8 to 17 a new framework completely for plugins, so you can find them, and it's very easy to use. I want to thank some of my colleagues about the example or for information they gave me. These are some books of MySQL 8. So introduction of MySQL document store, if you are looking for document store, but there is also the MySQL Connector Python as a book on itself. So feel free to do that, to have a look at it if you want. So thank you very much.
はい。ということで、では、以上ですね。MySQL テクノロジーカフェでございました。
はい。皆さんの顔が参加者の方にも見えていると思いますので、最後にご挨拶ということで、手を振っていただければ、私の方で
Alright, so Fred,
スクショ取ります。
marketing team will take a screenshot for the closing. So just say bye to everyone and wave your hands, and the marketing team will take screenshots.
I don't know if you hear me, see me, but my machine froze, it seems.
It seems like you're freeze.
Yes.
You're frozen.
I'm frozen.
記念写真を撮ろうとしたらまさかのここで固まるというですね。Well, it's good. It's not happening in the middle of presentation, but.
Yes, it's just now that it happened. Sorry.
すいません。記念撮影、スクリーンショットでやろうとしたらまさかここに来て固まるというですね。 オチがついたところで、今回のイベントをそろそろお開きとさせていただきたいと思います。皆さんご参加いただきましてありがとうございました。Thank you, Fred. Bye.
Bye-bye. Sorry.
Have a good day. No problem. Have a good day.
ありがとうございました。
ありがとうございます。